Hi everyone, welcome to EsteemPCB Academy. My name is Aviral. In Sigrity Aurora 17.4, return path workflow provides tables and visions to identify if signal is following ideal return path or not. In this video, I'll go over step-by-step process of return path analysis on parallel databases. We're also going to analyze simulation results, and for that, I'm going to use Sigrity Aurora license. To know more about this license, you can visit the link in the description. So let's get started. In the first step, we will open Sigrity Aurora 17.4 from Cadence program menu. Now you have to select a product, either Sigrity Aurora 2 or Sigrity Aurora, and click on OK. To open the board file, you have to go to File, click on Open, browse where you have saved the board file, select the file and click on Open button. In the next step, we have to select Return Path Workflow from Workflow Manager. In your case, if Workflow Manager is not opened yet, you can go to Analyze and click on Workflow Manager from here. Once the Workflow Manager is open, you have to click on drop-down menu, and from here you have to select Return Path Workflow. Alright, so first option that we got on return path workflow is set reference net. In this option, you have to select the net which is the return path of signal that you are going to simulate. In our case, it is ground. Now after setting the reference net, next step is to select all the signals we wanted to analyze for return path. And that we are going to select through select directed group link. So directed groups are groups of signal between two components. We call them start and end components. In our case, it is U7, which is a FPGA controller, and XU2, which is a DIMM module connector. So from this directed group selection window, here you have to select start component, which will be U7. So we'll just search U7 here and select it. And for end component, it will be XU2. And here we go, we can see all the entry of start and end components and all the net names between these two components. Now here we have to select which type of signals we wanted to include in the simulation. In our case, we want to simulate for single-ended and multi-drop. So we will uncheck differential and point-to-point signals. And we wanted to apply selections to all workflows. Now in the next step, I'm just going to show you how to add filter to select particular nets. So as of now, we have selected 94 X nets for return path analysis. I just wanted to do this analysis for all the data buses. To do that, I'm just going to put a filter here. Here we go. Now we have to uncheck this, right click and click over select all visible nets only. Here we go. So we have selected all the 64 bits of data bus. After that, click over create button. Apply and OK. Alright, till here we have selected reference net, group of signals for analysis. Now we are good to go for starting the simulation. To do that, you have to click over Start Analysis button from Workflow menu. Now it will ask you wanted to simulate the whole board or only the section which has these tracks. So in our case, the board is really large. It will take a lot of time to simulate. So we'll continue with the section which has all the signals that we have selected and click on Yes button. Once the simulation is done, which you can verify by green marker next to Start Analysis link, in the next step, we are going to see simulation results. To do that, you have to click over View Return Path table and the simulation table will open at the right hand side. Here we can see a couple of useful columns which has quality factor, start return pin, end pin and end return pins. Now here return path quality factor is ratio of actual loop inductance and ideal loop inductance. So if quality factor is approximately 1 or little bit around it, that means your return path is ideal. But in this case, as you can see, the quality factor is greater than 1. That means return path is non-ideal. Something is wrong with the return path that we need to find out. So we can simply sort this table in the form of decreasing order by double clicking over quality factor. So as of now, you can see the parallel data 22 has maximum quality factor. Now to view the simulation results, we have to click over Start Simulation in the Vision column. Here we go. Once the simulation is done, you can go to Visibility tab and from here you have to uncheck all the layers Now from here we'll get two options, vision net and vision layer. Vision net will be parallel data 22 and vision layer will be the reference plane underneath. So as you can see, so if I'll enable layer 3, here we can see the parallel data 22 track. I'm just going to select it. First we have to click on all off and select the net. Here we go. So this is our parallel data 22 bus. Now go back to visibility and enable VRs. So as you can see, it is transitioning from layer 3 to layer 7. And from layer 7, it is connected to FPGA controller. So for these two signal layers, we have L2 ground and L8 ground as a return path. So first we'll see the simulation results for L2 ground 1. Here we go. So it has maximum current density of 34 ampere per mm square. And similarly you can check for layer 8 ground 2. And it has maximum current density of 5.8 ampere per mm square. So as we have discussed in previous videos of return path analysis, you have to apply the same method to reduce loop inductance. And those methods can be adding stitching vias closer to vias, putting decoupling capacitors in case of reference plane change, and make sure there is no plane cutout where the signal is traveling. So that's it for this video. In this video, we have learned how to do return path analysis using return path workflow in Sigrity Aurora 17.4. See you in the next video.